Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard. I'm Richard on the MakeCode Forum.
I'm Joey at J1 on the MakeCode Forum.
And if you've been, whoa, okay, right. I forgot. That's where we left off.
Yeah, we left off on, the game just dies if it goes too fast.
Yeah. If you've been joining us for the past few streams, we've been working on an extension for doing layers of tile maps. So you can see right now we have a tile map with 3 layers. We have the brick border. We have this moving platform that's going left and right. And then we have this pink little stair step down at the bottom. And we have a lot of it working, but there are a few bugs that we have to work out. And that's what we're going to be doing today. Hi, Thomas.
Hi, sorry I'm late.
Yeah, no problem. Let me see if I can get back to the non-buggy state so we can... Okay, we're going to change this to 1. And see if we have, got it. There we go. Okay. So now you can see we have a platform that moves around that pushes our sprites. Great. Okay. And things get weird if you get squished, right? So when I get pushed over here, there we go. Now I'm squished, which is no good. Okay, so we were dealing with a bug that we encountered at the end of last stream, which I don't know what the cause is yet, which is when we cranked up the speed of this platform. I'm going to change this DX to 5. Now all of a sudden, when we hit it, we get an exception.
Mm-hmm.
So we're going to have to, figure this out. All right, let's just look at the call stack and see if we get anything.
Can we press the debug this project button just for fun?
This way? This isn't going to do.
That's not the other
no.
one. Okay, never mind.
This is not what you think it is, Joey.
Yeah, I forgot. I forgot there were different buttons in the text. Still a good button to press though in this case, maybe.
It just opens the debugger, which I don't want. Okay. So we're getting an exception at move sprite line 430. So that's going to be inside of physics.ts. And we can just scroll on down here to 430. All the way down. There we go. Okay. So we're doing is on wall S, and this dot can resolve clipping S. Interesting.
What does the actual exception say?
Yeah, let's hit it. Okay, so it says cannot read properties of undefined reading fields. And that generally always means it's an undefined thing, right? Unfortunately, my thing improving the error messages hasn't been checked in yet. And if we go ahead and go to scroll back down, this is why I didn't want to use the debugger. It's like not great in TypeScript. Okay. So this is where we're hitting it. And it looks like TM is null. Okay. So our tile map is not defined.
Suspicious.
Okay, so the reason that we weren't hitting this before is because we weren't clipping. But now we are clipping, and we're passing in this tile map, which makes sense because I don't think we are actually passing in a tile map. Let's go ahead and look for where can resolve clipping is called. Okay, well, we call it right here. And we're passing in game.currency.tilemap. So that's not going to work because this is not actually defined.
Yeah.
Okay. So why is can resolve clipping only called here? Shouldn't there be another place where this is called? I guess we only call this function when you set the XY of the sprite directly.
Yeah, this is just like the clip it or bump it out just a tiny bit logic.
Makes sense. Okay, so to fix this, we're going to have to go to our isOnWall function. Or I guess we just need to loop over all of our tile maps and...
So we can loop over them all, and that would be fine. Well, I guess that one ends up getting called from everywhere, doesn't it? So it kind of makes sense that it is. I guess that we are already doing that for the other section with the layers right there.
Okay. We're going to pull this into here. And then we are going to loop over all of our tile maps like we do in isOnWall. So let's actually go to isOnWall right here. I'm going to go ahead and copy this. Head back to where we were. I pressed the back button on my mouse, which is what I normally do in VS Code, but that does not work in the MakeCode editor. And it actually did a back, so the editor is gone from my URL. So if I press it a second time, we'll reload the page. So that's going to be that.
Does control and the arrow keys work? I feel like those will work.
Well, control and the arrow keys is skip token. I don't know what you're referring to.
Maybe I'm thinking maybe it's alt. What the heck is it? I'll figure it out. Oh, it's alt and the arrow keys.
Okay, no, alt and the arrow keys is also back.
Huh.
So.
Well, sorry.
That's all right. All right, where were we? Roll left, can resolve. Okay, right here. Okay, so for this, all right, so this function that we have right here, we're passing in this tiles.tilemap, but I'm guessing that inside here, all we're actually referencing is the scale. Okay, so we're going to make this be can resolve clipping 2. Because this is overridden from the parent class, so we have to give it a different name because we're going to be changing this thing. We're going to go ahead and call this, we're going to pass this tile scale, which is going to be of type number, whatever. And then just go ahead and put scale right here. All right, and that should, yep, no errors. That looks good. Okay, so we can actually change this back to what it was before. But we need to figure out what our tile scale is. So let's move this layers bit up here. And we're going to say, if let scale equal tile scale dot 16, and then we're going to say if layers dot length scale equals layers of 0 dot map dot scale. Else if tm, and I'm going to move this up. Then we're going to say scale equals layers, tm.scale. Like that. Not that I expect people to be using the tile map on the scene. It just feels trivial to support, so it might as well.
Yeah.
And then we're going to go ahead and just pass in, change this to 2, pass in our scale right here. And that should do it. So now, woo, okay. Yeah, so. Whoa. Yeah, all right. So this is working. Still weird things happen when you
kind of expected things, I would say, right? Like they're what you would expect to run into, which is that you're getting pushed through something.
Yeah.
You're getting pushed through something. And it makes sense that it resolves that one because that's the thing on top, so it's running last, so it's getting pushed that way and last.
Mm-hmm. Okay. Well, that works. So let's head back over to main.ts. We're going to go ahead and turn this back into a platformer. So we're going to do that. I'm going to comment this out and paste another one and make this VY V0 so that we can easily swap between them. So there we go. We're back to platformer, and now I can. Whoop. Okay, don't do that. Okay. Whoa. Okay. Go ahead and land on top. Nope. That didn't work. And land on top. Okay. All right. So this is not working.
Yeah, it seems like you're clipping through it.
Yeah. I mean, it seems like I'm clipping through the ground also.
I think what's happening is that you're clipping through, and then for some reason it's not getting set afterwards, unless you fall through immediately when you're falling.
I see. So we're getting into clipping state, and we're not getting out of it, is what you're saying.
Yeah. Right? Like once you get marked as clipping, we have to do something to unmark it. That's what the end of that function was doing. The squiggle equals.
Okay, so let's see. I think that should be happening somewhere already. Let's do clipping. Yeah, right here, right?
That feels like it should be. So then that would, I don't know why it's not.
Yeah.
Does that run tilemap collisions 2?
Yes.
It's a suspicious name for a function.
It's just like we did before. This is a function that's in the parent class, but we had to change the signature, so we just made a new function that called that. Yeah.
We should have done it the PHP way, which is like add tilemap collisions secure or not old or something like that. I don't remember why. I just know that PHP has a lot of things like that.
Joey's acting like I've ever written PHP code. I'm not from the 90s or work at Facebook.
It's solid for what it works, for what it does.
I took a course that had me take PHP code. Richard, you could have taken the same course.
I wrote PHP code briefly. What course was that?
Web development course.
If I remember right, I wrote a Pokédex.
The web and mobile.
Did I have to write PHP in that class?
I did, but maybe you had a different teacher.
I did write PHP at some point, but I thought it was in my compilers class, but maybe it was not. All right, anyway. So, okay, what are we doing? Right, so we need to figure out why this isn't clearing. So let's go ahead and just put a breakpoint, you know? I hate the JavaScript debugger. Right there.
Should it
go
be?
Up here.
Oh, never mind. Yeah.
All right. Well, that's not running. Okay. Right. So we should actually be putting our breakpoint right here because. Okay. Wait. But now we're in kind of a bad state. Okay. Let's restart. Okay. So I'm going to jump up. There we go. Okay. So we are currently marked as clipping. Let's step into this is on wall. All right. Now we have 3 tile maps. We're going to see which one we are overlapping with. So this is our outer tile map first. We should not be overlapping with that one. This is our inner tile map. So this is the platform that we're looking at right now, I think. So I'm guessing that this is the one that we're overlapping with. So let's step into this is overlapping wall. All right, and we have left, right, top, bottom. So this is 3 for the left, 5 for the right, top is 0, bottom is 2. Okay, so this should not be overlapping an obstacle because 3 is our if we look at the coordinates for our tile map, the rightmost tile is 0, 1, 2. So because this is out, we know that this should be Oh, okay, wait. I see what the problem is. Okay, so we have this allow out of bounds, right? And we're saying inside our is obstacle function. So this is set to true. We can see it right here. Allow out of bounds is true. But inside our is obstacle function, we're saying if the tile is a wall or allow out of bounds is true and we are outside the map. So this is the opposite of what it should be, right? This should be false.
Yeah.
So why is that?
Why is that not breaking other things? Good question.
I guess it's, maybe it was breaking other things just in a way that we wanted it to, I guess.
Yeah, I'm guessing we have inverted this check somewhere.
Yeah, it seemed like it thought you were colliding with the
Yeah.
platform.
So our is overlapping wall function is inside of, we call it here. Oh, and then so that's inside of our state. So let's head over there. Is overlapping wall right here. Okay, so we find, are we the first map or not? And this is indeed inverted. Should be not.
Gotcha.
Okay, well that didn't fix it.
I mean, it didn't fix it, but it did something.
Oh, this is overlapping wall. We need to do is colliding with. So this is what's failing. The is colliding with, because we are registering. This is what's being called inside of our. Let's go to our main.ts. So we have this move platform function, and this move platform function loops over all of our sprites, finds out if the sprite is colliding with the layer, and if it is, then we change the dx/dy. So this is returning true. This is colliding with. Oh, we also call is overlapping wall. Interesting. Wait, I'm gonna comment this out. Okay. So it's definitely this first part. So let's look at this is colliding with. Let's trace this. We're going to go over to custom.ts. So this is colliding with is calling get collision data and then checking is colliding with. So this get collision data, we're storing which layers we're colliding with. And we calculate that inside of our physics. So let's go ahead and do register obstacle. So register obstacle, this is where we are registering the obstacle, and this is where we store inside of that collision data which layers we're colliding with. So let's go to where this is being called. All right. So in here, we are passing in an allow out of bounds again. So let's see if we have once again inverted it. We're going to look for where tilemap collisions 2 is called. We are, yes, once again inverting it. Okay. This should be I does not equal 0. All right. Okay. All right. Well, you know, we're getting closer. Yeah. So we're still getting like clipping when we reach the edge.
Did you need to uncomment that section you commented out? Was that important?
No, that was an experiment I think we were doing last stream, but it's not actually what we want to do. Okay, so why are we clipping here? Well, that's because we need to implement, well, it's actually, you know, very good that you mentioned that code, though, because that is code that we have to mess with right now. So what's happening here? Basically, let me slow down this. How can I slow down this? Let's do inside of this game.update. Don't write this code I'm about to write, by the way. Right. Okay, so we can now go one frame at a time. All right. And if we look at how this thing is, okay, wait, I need to do 2 here. I'm going to do pause until A is pressed and A is not pressed. So this will, now I can advance 1 frame at a time. All right, so watch this platform right here. Okay, see how it is clipping through the wall. That's because our platform moving logic currently is not written very well. We're just kind of moving the platform until we get to a certain point and then reversing its direction, right? So you can see it's now going back in the other direction. So what's happening here is that when our sprite is being moved along with the platform, it is being moved into the wall, right? Mm-hmm. So that's no good. And actually, to show another error that this has, let's go into here. We're going to take our outer tile map, and we're going to go ahead and do this. Let's see. I want to actually make this so that it comes down right to where the platform is, which I think is going to be like right there. Just enough to like knock the duck over. Yeah, okay, this is good. Let me comment out my pausing code. Okay, so we're gonna land on this platform, and there we go. So you can see the same thing happening here, right? So I think it's a little bit clearer with this example. What's happening is when we get over here, we are not being blocked by this. We are being put like 5 pixels through. So even though I should not be able to get through this wall, if I actually land on this platform and then hold right, I get the timing right. There we go. It clipped right through. Right. So we don't want that. That's bad. So what we need to do is we need to change our platform moving logic to basically detect when we move the sprite, have we now started overlapping with the a wall? And if that's the case, then we need to bump the sprite out or whatever. All right. Okay. Actually, this code is important. I realize now what this is doing. Okay, so this code is handling the case where the platform moves into our sprite. Okay, so that's the thing that makes us get pushed like that, right? So we do need that code. All right. So one other thing to note, I'm going to change this back to 1. And we're going to go up here. Oh, wait. I don't know why I didn't land on it. What? Did I mess something up?
When this... Actually, I don't know.
So this is no longer working correctly.
Is it? I'm guessing, complete guess, that it thinks the duck is like out of bounds, and so it's no longer colliding when it's on top of the platform.
I think that should still work. Wasn't it working when the tile was moving faster?
Yeah. Huh.
Yeah,
Yeah.
it's weird. Okay. Well, we have to figure this out. All right. So let's go ahead and let's start by figuring this out. We're going to go to our physics.ts. And we're going to go to where we are checking our obstacle. And what should be happening is our sprite is moving into our tile map by some amount and being nudged out. Okay, you don't see this because this is happening in the physics step. So what should be happening is the sprite is on top of the tile map. It has acceleration, which is giving it a velocity in the downwards direction, which is causing it to move down a pixel or a fraction of a pixel or something. And then the tile map says, okay, now you're overlapping, and then nudges you back up, right? So that's the way our physics engine works. It does the move and then undoes it. And so in this case, that code is definitely running because we are not clipping through, right? We are getting pushed out. But for some reason, it's not registering the obstacle properly. So let's go to, let's go back to main.ts real quick. We're going to turn this back into a non-platformer so that I can control the duck a little bit easier. Okay, let's make sure we still have this issue. Yep, all right. So let's go ahead back over to physics.ts. We're going to go ahead and set a breakpoint. And then go back to physics.ts again. And we're going to do a control F for colliding or collided tiles. That's what we want. Okay, so we should be hitting one of these cases. Right here, or where's the other collided by tiles length check? Right here. Because we're getting nudged out. Actually, I think it'll be this one because this is the one that's messing with Y. So let me go ahead and press down, and there we go, we hit it. Okay. So now you can kind of see what's going on, right? So our sprite is moving, and by this move step, you can see it hasn't moved yet, but as soon as this physics resolution runs, it's going to nudge us back out and like stick us right there. The only reason we're seeing this state as it is right now is this is the frame before the collision takes place because we hit a breakpoint, which interrupted the paint.
Mm-hmm.
All right.
The rendering of the screen happens as a separate thing after all the physics take place. So that's what's happening here.
Yeah. You're a little quiet, Joey. Are you farther away from your mic than Jewel?
I think I'm about right here. Maybe I'm talking quiet. Or maybe my fan's louder and it's
Could just be my
It
setup.
sounds like my guess is it's the fan and the noise canceling
I see.
hitting your voice a little bit as well.
I can kill the fan for 30 minutes.
Okay. So we are indeed hitting this breakpoint right here. The question is, why is this not registering this as us colliding? So let's go ahead and step. Okay, so we have a tile. Let's look at our tile here. There it is. Null. That's interesting.
Wait, there's a tile further down. What? Oh, sorry. So up. There's a little arrow there.
Oh, there you go. Oh, these must be shadowed. So this is indeed the one we want. Okay, so we have image 88, top 37, left 60. Sure. Tile index null. All right. Well, sure. I believe it. Okay, so this is calling register obstacle, which is passing in our tile map, TM. So let's go ahead and step into this. Okay, so we're calling register obstacle. We don't actually care about that. And then we're calling get collision data.register. So this is what we care about. So we have our layer. Our layer is our tilemap layer. There we go. We can go ahead and look at the map real quick. So you can see that the layer is 3 by 1. And that is indeed what the dimensions of this one is. So we know that this is definitely the tilemap that we're looking at. So we're going to go ahead and step into this. Don't actually care about this. Step in here. Okay, so, all right, so it's registered. Let's actually, I don't think we'll be able to see it because I don't think data shows up here. Oh, hey, data does show up. Oh, hey, there it is. Oh, hey, collided with. Oh, hey, there it is. Tile map layer right there. Hey, that's nifty. So this is these indexes here are the collision direction. 3 means that we are colliding with the bottom. So that means that we are colliding on the bottom with this tile map layer, which is what we want. Okay. So that works. Let's go over to main.ts. We're going to go ahead and put a breakpoint right here. There we go. Okay, so now we're here. And we're going to go ahead and step into this. So is colliding with, step into that again. Okay, I think we're right now inside the state function. Yeah, so I'm going to step out of this and then step into the next one. Okay, so now this should be inside is colliding with. Wait, we're in physics.ts right now. Okay, wait. I don't know where we are. We're inside move sprite. Okay, all right. So that means that we did collide, right? If I go back to move platform, yeah, okay. So we're changing left by dx. All right, so we should be changing left by -1. So what must be happening is that for some reason this is getting negated. So I bet what's happening is that because this is moving by 1 pixel, we have once again messed up the is clipping resolution logic. So it's being like, oh, you're just overlapping by 1 pixel. Let's go ahead and nudge you out of there, you know?
That makes sense.
So we're going to go back over to physics.ts. We're going to go back to can resolve clipping. And we're going to put this right here and see if we hit it. Okay, we didn't hit it. All right, well, that takes care of that theory. Well, it's good to have it invalidated quickly. All right, so if that's not the case, then why isn't our x changing? All right, so we're gonna put a breakpoint right here in this move spray. Oh, I'm hitting it. It's just not revealing the line correctly. Okay, so here we go. We are changing the x by this dx, which is -256, which because of fixed point, that's -1, right? I think. What's -1 shifted left by 8?
That sounds right.
Yeah.
Okay.
Do it in the terminal. Let me see.
So this should be changing our x. Let's just go ahead and do step.
Okay. Yes, it is. Yes.
Okay, creating a moving sprite. And then we're calling tilemap collisions for all of our layers. So let's look at our X right now and see which layer is causing it to change. So our X currently is 7936. This is the secret X that is in fixed point coordinates. So Thomas, you're in charge of remembering 7936.
7936.
All right.
I'll take it to my grave.
Step, step, step.
Well, I mean, don't take it to your grave. Just keep it for like 30 more
That's true.
seconds.
I want you to tell me about it before you die. So tell
Oh
me,
yeah,
then die.
wrong expression. I will remember it for the rest of my life.
Okay. I just hope that's quite a long time and not just,
Yeah.
Okay, so far we still have an X of 7936. All right, we just did the second layer and our X has changed to 8448. Okay, so we collided with whatever the last layer was. So that's the second layer. So we registered a collision with this one right here, and it bumped us out. Okay, so we're just going to hit continue and get back to here again. Okay, so now we're back into move sprite. We have a dx dy of 0. I'm not going to, just go ahead and hit continue. Continue again, dx negative 256. Okay, so we're back to where we were. This is great. We're going to now go into tilemap collisions. Oh, right. We already set breakpoints here.
Mm-hmm.
So
we could put it into the bucket of, and we'll probably never do this, but conditional breakpoints would be nice to include here. So we could have like,
oh God, we'll add it if you implement it.
It might not be the worst, right? We already just are injecting like a breakpoint. It would be annoying, but not the worst.
It would be the worst. I don't know what you're talking about.
Really?
Yes.
We have the variable there.
That'll be terrible. I promise. It'll
I
be
mean,
terrible.
it wouldn't be good. It wouldn't be good. I don't know. Okay. I have to revisit that.
Because you need to, there's two ways of doing it, right? So one way is recompile the program, okay, which is how we currently do breakpoints. Mm-hmm. Well, actually, currently we just have a array of Booleans basically saying which each breakpoint is hit or not.
Yeah.
So you could recompile the program and say, okay, this has a breakpoint that should hit when this condition is, and then you compile that code into the program at that point, okay? So that's going to be very difficult to do because of how our compiler works. You will basically, we are so teed into the TypeScript compiler, you will basically have to intercept the TypeScript file, inject this code into the correct place, and then do the compilation to this thing that flags it as a breakpoint.
And then not mess up the existing breakpoints.
Okay. And then have source maps to make it all map to the user's code back at the start. All right. So that's option one. And it's bad because it also means it's going to reset your program every single time you set a conditional breakpoint.
Yeah.
Okay. Option two is you eval the code. All right. So you would basically have to store symbol information so that you could resolve variables in order to compile this expression on the fly, which we do not currently do.
What about option 3, which is awful? I know.
Wait, I can't hear you, Joey.
Okay, what about option 3, which is awful, and I know it?
So.
I can hear Joey. I can hear you just fine, Joey.
Okay. Option 3, which is we do break on the breakpoints, but then the first thing we do when we read it is we check the variables that are in the message we got from the breakpoint and immediately send a continue when we Don't hit it.
Wait, sorry. You have to start over again. I couldn't hear you.
Option 3 is where, currently we send the message back with all the variables and stuff when we hit the breakpoint, right? We check it at
Right.
that point, and then we send back a continue immediately. That's not good. It's chunky, and it'll slow everything down.
That
But-
won't work.
No?
No, because
We have the
unless
variables.
we don't have the variables in a way that is easy for us to use. All right.
That's true.
So we would basically have to implement our own thing for parsing the expressions, determining if it's like a property access expression or something, and then we would have to compile it. At the end, you would have to write a compiler. That's what would happen.
Is that? I mean, just looking at these guys, like the variables. These are basically the results that we get sent back with the breakpoint. No variables, or am I misremembering where these variables?
They
come from?
are, and if you just want to do a top level check, like that would be okay. But if you want
That's
to
what
say, if you want to say
I can't.
s dot x equals 10, okay?
Oh, of course, that gets messy really quick. Yes, I was imagining it for the very, very simple case, but yes, that is fair. That is extremely hard. I was thinking just the dead simple dy equals 0 and just having like a drop down.
Even that's going to get tricky though, because of our
Yes.
any types and things. It's not. Yeah.
This is why we should just use the Open VS Code button. It has a debugger there.
No.
Would
That
that
won't
not work?
No.
What?
I mean, it wouldn't work, but we should do that anyway.
They have conditional breakpoints.
They have conditional breakpoints, but the debugger relies entirely on our debugger implementation.
Oh,
So they provide the UI for it, but it doesn't magically work. We're not running in the JavaScript debugger, so we would have to implement our own debugger that supports conditional breakpoints.
Yeah.
gotcha.
So that means that if we do it for this, we can do it for that too.
That's true. Yes. So Joey, when you do that, we can turn it
Yeah,
on
but-
everywhere.
Okay, sounds good.
I want it on my desk by Monday.
Okay.
All right. Okay. What we're doing. All right. So we have this breakpoint right here with this collision direction. Make sure we have the other one hit. Okay. So we don't have that one set. So go ahead and set that one too. And we're going to go ahead and hit continue. Okay. So in the call stack, we want to see this in move sprite. Yep. Okay. And we should have a layer passed in here. Let's make sure it's the layer we think it is. So TM map 3.1. That's right. Okay. So this is the correct one. We have detected that we're colliding with it. Let's see which direction we're colliding in. So this is when we are moving vertically, it looks like. So let's look at what our dx, dy are that got passed in here. Okay, so we passed in a y diff of 0. And we passed in an x diff of -1. Okay, so we moved our x by however much amount. Where's our x diff? Yeah, so we moved it by -1. Then we checked vertically all of our obstacles to see if we hit it or not. And so we detected that we collided with something. So that means that we have this collided tiles array. So in here we have this static obstacle, and this should have a, oh man, we don't have the column row, which would be very helpful. Okay, we can figure this out. So we have the top and we have the left. We need to calculate these relative to the top and left of our tile map layer. Okay. So the top of our tile map layer is 60, and we collided with 24. Are these not actually? It's possible that this obstacle is lying to us.
I guess that must be that it's relative to the top. Well, no, that doesn't make sense either, because these are 3 by 3 wide, and so why is the top 24? Wait, no, that doesn't make any sense at all. Top 24.
Okay. Well, let's see. So let's set a breakpoint. Okay, we're gonna reset. We're just gonna hit continue. Get back to move sprite. There we go. Okay, so now we're here again, which is great. Okay, wait. I need to set this breakpoint right here. So we want to see when our obstacle is registered because this gives us our column row. That's what this x0, y0 are. Right. Continue. Okay, move sprite. Okay, so here we go. This is when we're hitting our obstacle. So in here, we have an x diff 0. Okay, no, this is the physics. Let's go ahead and continue again. We want to keep going until x diff is equal to negative 256. Now, you know what? It's possible that this is never going to happen again because we're no longer colliding. Okay, we're going to hold the down button.
I'm wondering, because we register the collision, we're like going down, we get embedded into the platform. And so we're going to we correct that.
Yeah.
We correct that before. Okay, never mind. I think then we try and do the horizontal movement, but that we should have corrected it by then. So we're not going to collide with our horizontal movement because we're still embedded in the wall.
So I realize now the order of events is really important for this. So physics runs first in the game loop, pretty much. There is other stuff that runs, but for our intents and purposes, it runs first. So that will be when we clip into the bottom and then get kicked out, right? Then the physics finishes, on-game update runs, and that is where this move platform is being called. So then we are calling move sprite, which is calling this function a second time.
Okay.
Yeah. So the reason that I'm saying I'm not like pausing here is because all of these x diffs that we're getting are 0. And these y diffs are 870. So these are all the physics ones we know because we're not trying to move. So we may have to just clear all of these breakpoints.
Mm-hmm. We can implement our own manual or conditional breakpoints.
No. We could do that, actually.
You can do that in the game, but you can do that in there by just putting in an if statement, right?
You can do an if statement, and you can put in a debugger call if you wanted. I do believe we support the debugger keyword.
Even if you don't put a debugger, just put a console log in the you can breakpoint on it.
All right, so we're going to go ahead and get ourselves back into the state. And I want to go to our code up here. We want to be where x diff is equal to 0 or not equal to 0. So that's this one right here. And we want to set this breakpoint right here. All right. So I'm going to press down now. And this should not trigger until we hit the platform. There we go. We hit the platform. Okay. So there we go. Our x diff is negative 256. Our x0 is negative 1. And our y0 is negative 2. Okay, and allow out of bounds is false. Okay, so this is what the problem is. Allow out of bounds should not be false here.
Should not be false here.
Yeah.
Because this is the not the top level or the bottom, whatever, the main tile map. Which is however we refer to that at the bottom, I guess. It should be false.
Yes, allow out of bounds should be false for everything. So we just flipped this again.
Oh.
We fixed it one place. We didn't fix it here.
Perfect.
There we go. Okay, all right. Well, the fun of debugging things. All right. Turn this back into a platformer. Okay. So now you can see that when we're moving 1 pixel at a time, we don't have any clipping issues. And that's because 1 pixel is enough for the clipping logic to automatically fix it, right? Because the clipping logic will at most move you 1 pixel. But if we change that dx to be higher again, so let's go back to 5, which again is going to make it just go crazy. And then we land on this platform very carefully. There we go. You can see it immediately shoved us into the wall, which made us clip. So there you go. Once again, you can see if I'm like 3 or 4 pixels into this wall up here, if you draw a line down.
Yeah.
Okay. So to fix this, we need to.
I guess for one part of this is when we say we only move you out 1 pixel, that's like an intentional choice more than anything, just for anybody watching's sake.
Yeah.
Because we don't want you to like be forced to push out or like, make it like visibly weird that you're getting pushed way out of where you suggested putting it. But we can make the decision to change that for this alternate physics engine if we want to be a little bit more robust and just change that clipping logic.
That is what we're going to do, kind of.
Yeah.
So like Joey said, the reason that we have clipping is because if you have a sprite and you say it should go to XY location, it should go to XY location. We want to support that. You should be able to put it wherever, right?
Yeah.
However, mistakes happen. Sometimes you're 1 pixel off, okay? Yeah. And for that, we go ahead and say, okay, we can actually just nudge you a little bit and then you won't be clipping. So we fix that. Mm-hmm. But if it's anything bigger than that, then we go, they know what they're doing. They're the smart programmer. Let's make sure that we put the sprite where they told us to.
I guess they know what they're doing, or they will be able to see it and they'll feel awkward if we move them like 5 pixels over, right? One of those two.
Yeah. Okay. So what's tough here is we have our sprite. We can move it just like we do for the physics. But the problem is that this tile map will not have moved when we do the move. Okay? All right. And so the reason this is a problem is let's consider the stair step. All right? So let's say my sprite is on this platform and is just like right up against this corner. And we have this guy moving to the left. Okay? So with our current logic, what we do is we would move our sprite to the left, and then we move our tile map to the left. And because they move together, that means that, they're going to be in a valid position. So when we move our sprite to the left beforehand and we treat it like we do in the rest of the physics engine, it's going to bump against this corner and not move. And then this tile map will move. You get what I'm saying? So the sprite will get left behind. So in order to fix this, we need to move our sprite and we need to run the same collisions as the physics engine, but for every tile map except for the one that it is riding on.
Sounds reasonable. Yep.
Yeah, because in theory, if our tile map moves by the same amount that our sprite moves, it will. Well, there's two outcomes here. Either the move will be valid and everything is okay, or the sprite will move, then the tile map will move and will be overlapping with the sprite. And if that happens, it means we got squished, and we need to do something there. Game over or whatever. Mm-hmm. Okay. Well, we're kind of out of time here, but that's what we need to do next. So I'm just going to leave a comment to remind us. I don't know if we're going to work on this on Friday because we might do something else on Friday. But let's put in a comment here. So add a move sprite API to physics engine that lets us move with the normal tilemap checks, except for whichever map the sprite is traveling on.
How will that work if they're like, if it's a stationary? I guess we just wanted to coin this. If it's a stationary tile map and they're just walking along like the platform.
Yeah, if it's stationary, then this move platform does not get called. So,
get called.
yeah,
So,
not an issue.
Fine.
All right. Well, that's going to be what we work on next time we work on this. Hopefully, we'll be doing something else on Friday. But reminder, we have a mini game jam going on right now. That's up on the forum. It's destruction themed. So yeah, make something cool. Destroy a bunch of stuff. Mm-hmm. Also, reminder, this came up on the forum. Someone was pinging me about it. The next big game jam will be in October. So look forward to that. That's the plan. We're trying to align with school years a little bit to make it easier for teachers to play along. So you have to wait through the whole summer, but yeah, that's it. I'm Richard at Richard on the MakeCode forum.
I'm Joey at J Wonder on the MakeCode forum.
And I'm Thomas at Sparks on the MakeCode forum.
And we'll see you on Friday. Bye, everybody.